What do we have here? Zero array transformation. Medium, okay. You're given an integer array nums of length n and a 2D array queries, where queries of I is some three-element tuple, left, right index, and a value. Each query and queries represents the following action on nums. Decrement the value at each index in the range L in the range left index to right index in nums at most value I times. Okay. The amount by which each value is decremented can be chosen independently for each index. Okay, so you can decrease some group of values within the array by some amount, up to some amount, and it can be different for each one. Okay, a zero array is an array with all its elements equal to 0. Okay. Return the minimum possible non-negative value of k. Return the minimum possible non-negative value k, such that after processing the first k queries in sequence, nums become a zero array. If no such k exists, return -1. So you want to identify the lowest possible index within the array. Okay, so like each query basically lowers your nums array, I think, and then you want to do as little as possible to get it all down to 0. Okay, so your nums array is 202 here. The first query is you can lower basically all the elements, left index to right index to 02 is all the elements, by 1, so it becomes like 101. Here you can lower another 1, all the elements, so it becomes 000, so it should be returning 2. Okay, the minimum value k equals 2, yeah. So you have a nums array here is 4321. If you do 1 to 3 lowered by 2, you're lowering these by 2, and it becomes 4100. So you need another one. 0 to 2 lowered by 1, so this becomes like 4, or becomes 1, no, sorry, 3 0 3 so the first one you lower by 2 each one of these, so it becomes, yeah, the first number never becomes 0, it becomes a 3. So you return -1 because there's no queries there. Okay. Okay, this seems pretty straightforward, I think. Seems pretty straightforward. Or at least understandable. So let's just start with something basic here. We'll have n is the number of queries, or number in our nums array. So, and let's say qn is equal to number of queries. And answer is going to be originally -1. Alright, so we can't, it wouldn't be very fast to process each query manually. So, like if the query is if the number of elements in the array is, let's say, what was this, 100,000? If there's 100,000 elements in the array, and your query of I is going from 0 to 900,000, or 0 to 90,000 decreased by 1, you're not going to want to do all that processing. So how to efficiently store compactly store that processing. So what you could do is you could have one method might be to do a binary search or to see whether or not it can be done within the ith query. So let's say there's 1,000 queries, right? How many queries are there? Possibly. There's actually possibly 100,000 queries. But let's say there's 1,000 queries. So if you do a binary search where the search is let's see, binary search to find the ith query where everything after that has a 0 array. If it works for that query, then it works for every query after it. So there is some kind of threshold point where the ith query works, and then the ith plus 1 query works, and the ith plus 2 query works in terms of it will still be a 0 array. So you just need to know whether or not the ith works or the ith doesn't work, and you can kind of narrow it down. It's like a hot cold thing. This would work as long as each determination is basically O of n. So if you can do a linear check to see whether or not doing I queries would make it a zero array, then the overall thing would be n log n, where binary search is going to be log n, and your number of elements in your array is n. Question is, can you do it within a linear approach rather than a binary search approach? No, I'm also glossing over the fact that I haven't really done even any approach that makes any determination by the nth query. I feel like there should probably be a linear approach here. So what you could possibly do is for each spot in your array, for each spot in your array, you can't really determine. All right, I'm gonna try the binary search way because I think it's actually fairly straightforward to at least see how that looks. So how the binary search would work would be you process I number of queries. So say the low number of queries is 0, the high number of queries is qn minus 1. And then you define a binary search is possible. So num queries. What's this? So here this is a function that will determine if processing X queries. Okay. As makes a zero array. They return true if so, false if not. So here what we can do is we can make a an array of changes kind of. So basically if you think about each query as having some bounds to it. Let's say okay, so let's say this thing, right? If you were to